Good morning, student. Today we are going to learn about packages of Xilinx, concept of FPGA with standard cell-based design, VHDL for design synthesis, and introduction of Raspberry Pi. After the completion of today's session, you are able to discuss the packages of Xilinx, explain the concept of FPGA with standard cell-based design, describe the VHDL for design synthesis using CPLD or FPGA, and discuss about the basic idea of Raspberry Pi. First we discuss about the packages of Xilinx. So, during assigning packages, power requirement of a user need to be considered. For each device, suitable packages are chosen to handle its design and gate utilization. Sometimes, without any external heat management, primary or internal heat removal casing works well due to proper choice of a package. Day by day, the need arises for customers to utilize an FPGA device beyond typical design parameters. For these situations, only primary package not able to handle the heat removal without help of external heat management. Heat has to be removed from a device to ensure that the device is maintained within maximum temperature limits. Why? If heat buildup becomes excessive, the device temperature might exceed its limits. Because of the high temperature, the device might fail to meet the speed file performance specification, or we can say it is not able to operate it or give its performance up to the mark. Okay. In addition to performance considerations, there is also the need to satisfy system reliability objectives by operating at a low temperature. So, failure mechanisms and the failure rate of devices have an exponential dependence on the device's operating temperature. Thus, the control of the package and by extension device temperature is essential to ensure product reliability. Okay. So, electronic packages provide electrical connections between the IC and the board and efficient removal of heat generated by the device. Feature sizes are constantly shrinking or decreasing, resulting in increased number of transistors being packed into the device. Electronic packages must be flexible to address high pin counts, reduced pitch, and form factor requirements. Xilinx provides a wide range of leaded and array packaging solutions for advanced silicon products. Packages from Xilinx are designed, optimized, and characterized to support the long-term mechanical reliability requirements, as well as to support the cutting-edge electrical and thermal performance requirements for our high-speed advanced FPGA products. In modern high-speed logic devices, it consumes an appreciable amount of electrical energy. This energy invariably turns into heat. Higher device integration drives technology to produce smaller device geometry and interconnections. With chip sizes getting smaller and circuit densities at their highest levels, the amount of heat generated on these fast switching CMOS circuits can be very significant. Okay, this is all about packages of Xilinx. Next, concept of FPGA with standard cell based design. The cost of designing traditional standard cell based design is increasing every year. The standard cell based design is also known as ASIC, means application specific integrated circuit, ASIC designs. In addition to this, development costs are increasing due to design complexity. Issues such as power requirement, signal integrity, and manufacturing defects can add significant risk and time to market delays. FPGAs offer a competitive and viable option to traditional standard cell based design or ASIC designs development by reducing the risk of high cost and time to market delays, etc. With the availability of multi-million gate FPGA architectures and support for various third-party EDA tools, we can use a design flow similar to that of traditional standard cell-based design devices to create system on a programmable chip designs in FPGAs. With the device sizes and architectures that are available today, FPGAs can effectively implement systems that were once possible only in traditional standard cell-based design. Because of their programmable capabilities, FPGAs reduce the time to bring up a system as well as minimize the financial risk involved with new designs. So, Cyclone series FPGAs provide a low cost alternative for applications that currently use low to moderate density traditional standard cell based design. Okay, so this is all about concept of FPGA with standard cell based design. Next is the VHDL for design synthesis using CPLD or FPGA. CPLD means complex programmable logic device and FPGA is field programmable gate array. So here first block is VHDL program. So VHDL design flow starts with writing the VHDL program. Various manufacturing companies like Xilinx, Altera, etc. provide their own software development tools like Xilinx ISE, Altera Quartus, etc. to edit, compile and simulate VHDL code. In this VHDL code, the circuit is described in RTL, means register transfer level. Next, this VHDL code is compiled and it generates netlist at gate level. The compiler converts high level VHDL code in RTL to gate level. So, gate level netlist contains the information regarding logical connectivity of all standard cells. Here, the components are generally gates. So, a netlist is a connection of gates. At RTL, we describe the behavioral functionality of the circuit. At gate level, the netlist describes the logical functionality of the circuit based on logic gates. Okay. Next, this netlist is further optimized to get optimized netlist. Again, at gate level optimization, or we can say optimization is done for better speed and less space. The simulation of design is done at this stage. Last one is the physical device. Finally, a physical device is implemented on CPLD or FPGA, or final mask is prepared for ASIC from this optimized netlist by place and root software. Once again, the final device can be simulated and verified. So this is all about the design synthesis. Next is the Raspberry Pi. Raspberry Pi is the name of a series of single board computers made by the Raspberry Pi Foundation, a UK charity that aims to educate people in computing and create easier access to computing education. The Raspberry Pi launched in 2012 and there have been several versions released since then. The original Pi had a single core 700 MHz CPU and just 256 MB RAM. And the latest model has a quad core 1.4 GHz CPU. This one is the latest with 1 GB RAM. All over the world, people use Raspberry Pi to learn programming skills, build hardware projects, do home automation, and even use them in industrial applications. The Raspberry Pi is a very cheap computer that runs Linux, but it also provides a set of general purpose input or output pins that allow us to control electronic components for physical computing and explore the Internet of Things, means IoT, means using internet. There have been 3 generations of Raspberry Pi, that is P1, Pi 1, Pi 2 and Pi 3. And there has been a Model A and a Model B of most generations. Model A is a cheaper variant and tends to have reduced RAM and ports like USB and Ethernet. The Pi 0 is a spin-off of the original generation, made even smaller and cheaper. The Raspberry Pi operates in the open source ecosystem. It runs Linux and its main supported operating system, Raspbian, is open source software. So this is all about today's class. Thank you.